the basicity of amines. And the thing that we have discussed is inductive effect. What did you find? Plus I effect increases basicity. Minus I effect decreases basicity. Then resonance effect plus R effect increases basicity, and minus R effect decreases basicity. Is it not? Please write the summary. Then we will discuss later. Finished?
Yes, sir.
Okay. So now we are going to discuss, in this case, we have found, because of this effect now, tertiary, because of inductive effect, we have found the tertiary amine is more basic than secondary than that of primary in either in gaseous state or in non-polar solvents. Why do you mention this condition? Now we'll see why you have mentioned. Third is the solvation or hydration effect. Okay, we'll write now. Hydration effect, or you can say basicity of amines in aqueous solution. See, when we call a substance base, a substance can be called base only when it reacts with an acid, because it is a question of comparison. If base is not there, then you cannot compare its property. Just like if the darkness would not have been there, then we could not appreciate the brightness. All right? So, and I had been telling you repeatedly, any chemical reaction or any physical process will occur only when its future step or the product is more stable than the previous step. Otherwise, it will not occur. This is the law of the nature. So let me write these three three amines. So right now here, this is primary amine has reacted with an acid and it is going to form corresponding ammonium salt. So this is primary ammonium salt. Okay, we have done in aqueous media. So this also will be in aqueous media. So now see here, this is primary amine. I think I'm taking too long for this chapter. Chapter is not that big, okay? But each and everything you have to understand. And there is no point of going for extra tuition or help. You can read your textbook, finish. And secondary. Hello, Aditi.
Yes, sir.
কালি তো ক্লাছত আহিছিলে না?
Oh, nice, sir.
So see now here, this is the same. So primary, secondary, tertiary amine, they have reacted with an acid in aqueous solution, and so let us see their fate, whether everyone has the same stability or less or more. See here, hydrogen is bonded to the nitrogen. Please remember one thing. We know nitrogen lone pair, nitrogen donates this lone pair. So amino group are always considered to be electron donating in nature. When nitrogen attains positive charge, or we can call it is quaternary state, that time it is one of the strongest electron withdrawing group. Why? Because nitrogen wants to get it back its electron. So this is moment it becomes highly electron withdrawing nature, all the nitrogen hydrogen bond become extremely polar. So immediately hydrogen requires assistance from someone to supply electron. And we know the benevolent water molecule is there ready to help by electron. See here. So immediately form hydrogen.
Sir, can you explain again?
When
Sir, that part is where that bright spot is, sir.
See here. When we take amino group, what is the valency of nitrogen? Here 3. Electronegativity of nitrogen is less. So immediately nitrogen gives the electron to others. Because of that, it is a Lewis base. When nitrogen attains tetravalency, when it has donated this electron, then this nitrogen character changes. It wants to take back the electron. Okay? See, bank are always asking you to take loan. You go and apply, you get a loan. Once you take the loan from bank, what happens? Bank still gives you money, or bank wants the money back?
Wants the money back.
Yes. So when nitrogen has given this electron, lost its lone pair, at that moment nitrogen changes its character. It becomes one of the strongest electron withdrawing group. It starts pulling the electron from the neighboring atom. So these 3 hydrogen become highly electron deficient. So what to do? In that case, they borrow the electron from water, and that results in the formation of what? That results in the formation of hydrogen bonding. Okay, so now I'm removing AQ. Why? Because already water is there around here. See here. So this primary ammonium ion forms 3 hydrogen bonding. Then secondary forms 2 hydrogen bonding. And tertiary, which did not have any hydrogen, we have already seen its boiling point is the minimum boiling point because it does not have any hydrogen bonding. But after the formation of this ammonium ion, it has one. So you tell me, which ion will be more stable in water? Look at this and tell, which ion is more stable in water now? Is it tertiary or primary? Tell.
Primary.
I've already drawn it for you. Which is more stable in water now?
Primary.
Primary. So in that case, see, if you go by the inductive effect theory, tertiary amine is the strongest because it has 3 electron donating alkyl group. Moment I put it in water, we find the situation has become reversed. This ion is more stable, then it is more stable, and this is the least one. So in that case, in aqueous solution, the basicity, order of basicity changes. In aqueous solution, primary amine is more basic. Why? Why it is more basic? Because its future step is more stable than the previous one. In this case, its future step is less stable than the previous one. So please write, then after that we will write the statement. Write down. You are very interesting. So let me, can I rub it? Hello?
Yes, sir.
Right. In aqueous solution. Wait, let me first find out where is that moon. In aqueous solution, the basicity of amines is, right here now, primary amine is more basic than secondary amine and tertiary. It is because of the higher degree of hydration of corresponding ammonium ion by their association with water molecules through hydrogen bonding. Okay. So if the question comes, arrange the order of basicity of amines in waters. So what we are going to write? So I reckon right now in the summary. Basicity of amines. I'll write now here in gaseous phase or in non-polar solution. Non-polar solution means it may be in benzene or ether or something like that, where hydrogen bonding is not possible. In that case, what you find? That you'll find, say, tertiary amine is trimethylamine is more basic than dimethylamine. Then in methylamine. So this tertiary, secondary, and this is primary. Okay. All right. B. In aqueous solution, you will find is just opposite. Tertiary, secondary, and primary. So please remember. So whenever this order of arrangement is given in the question paper, be little careful and see whether they have mentioned any medium or not. If they did not give any medium, write this. Tertiary more than secondary and primary. Or if you want to be a little bit careful, then you write the condition and write both the arrangement. So they discuss the another effect, that is called 3. This is called steric effect. Steric effect means what? The problem of space or effect of space. Steric effect. Steric effect is unpredictable. Sometimes it enhances the basicity of amine. Sometimes it decreases the basicity of amine. Okay, so let me just give you one example. Just now I have told you that tertiary amines are more basic than secondary. Okay, so let me write it.
গাড়ির আওয়াজটা বুঝে গেল।
What is this? Can you tell me what is this? Hello? What is the name of this one? First molecule. Can you hear me?
Yes, sir. We can
Yes,
hear you.
sir.
What is the name of this?
N-triethylamine.
Is correct, but the name is little wrong. If you go for classical name, is better. We call it triethylamine. And if you want to go for IUPAC name, then one you have to consider as the main chain and other two are substitution. In that case, it should be NN-diethyl ethanamine. So better, we go for the common name. Common name is always better. Chunu, Munnu, Lalu, these are all good. Khadu, Badu, like this. It is triethylamine and diethylamine. Okay, now see. Why do you
Sir,
call it this? Yes.
the valency of carbon atom in that triethylamine.
Kublai. Okay. Now, we call them base because they have lone pair. Please remember, H plus ion does not come to it. It is the lone pair who goes and approaches. The lone pair only goes and approaches the H plus ion. Okay. See, suppose you got a slap from your mother in the morning. Do you go near to her and tell, Mom, please give me a slap? Or she comes to you? Hello? All right. Yeah. Then in that case, it is this molecule will go and lone pair will approach the H plus ion. See now, look at this lone pair. Is it not being covered by two alkyl group?
Yes, sir.
So because of that, even triethylamine has 3 electron donating alkyl group, but because of its geometry, now it becomes ineffective because the lone pair is being covered or enveloped by alkyl group. If the alkyl group become bigger and bigger, in that case you'll find that basicity will decrease. Okay, so we have spoken enough theory. We have talked about inductive effect. We talked about resonance effect. We talked about hydration effect. But let us talk about the geometry. See here, due to geometry, the molecule is being crippled. So in this case, what we'll write? We'll write that the basicity of triethylamine is less than diethylamine because the lone pair on nitrogen is sterically obstructed by 2 alkyl group. Okay, so we'll write down. Right. In most trialkylamines, the basicity is less than corresponding dialkyl amines. Okay, so here we'll write tertiary amine, and here we write secondary amine. Even though the groups are electron donating in nature. Okay, but please write this, then you write this. Then I'll rub. I cannot write below because if I bend, no, then I develop back pain. গরম জল বের হয়ে ডাল হ্যাঁ অলরেডি সব সারাদিন তো করতে হবে গলা নিয়ে Can I wrap this portion? Yeah.
Yes, sir.
Right now. It is because the lone pair of electrons on nitrogen atom is covered by the larger alkyl group and cannot effectively participate in proton abstraction. All right. So thus, what will the basicity? Basicity will be, see here. You'll find here dimethylamine is more basic than trimethylamine then and methylamine. So here we have shown how the steric hindrance has decreased the basicity of amine. Now I'm going to show you how steric hindrance can accelerate the basicity of amines. This is important for your exam. They cannot effectively participate in proton abstraction. Write fast. Otherwise, one full year I cannot finish.
Done, sir.
Yes. Now see, how does it increases the basicity? Huh? Okay, see here. Here in this case, why in case of alkali amine, basicity decreases? Because alkyl groups are free. They can change their direction in the space. But if you have tied this alkyl group, or if the alkyl groups is being made rigid, in that case you will find the basicity will not change. See, take the example. Again, I write the same example. This is absolutely for your this is ethylamine. So this is this. So I'm going to write one more example. So it is see here. See, this is it has two carbon, 1, 2, 1, then 2, 1, 2, 1, 2, 1, 2. Okay, 1, 2. What is the difference between this? Because three alkyl groups are being joined from the back side. When they are joined from the back side, in that case you find this alkyl group which are in the back now cannot come in front. In this case, these ethyl groups are they have the full mobility. It can be like this, it can be like this. Next moment it will be like this. I told you in case of amines, this type of conversion of structure takes place very fast. We call them as Walden inversion. In this case, it is not possible. Look here. So you have the lone pair here. Please remember, lone pair orbital is larger than that of the bond pair orbital. Look here. So now, in this case, what happens? Due to the larger size, there is lone pair bond pair repulsion. How to avoid the lone pair bond pair repulsion? In that case, this loop becomes a little longer. See, when you sit in the back side of the Maruti taxi, if three of you are sitting, all of you may be in the same line. Okay. All of you in the same line. The moment the fourth person comes, what happens? Then you, just to accommodate yourself, you are being pushed a little outside. So similarly, because of this, see here, is it not the size of the lone pair increases? So if the hand is like this, now it is being stretched. It can immediately go and pick up the hydrogen from there. So in this case, due to steric hindrance, basicity is increased. In this case, due to steric hindrance, basicity is decreased. So, okay, so this is an example only for your intersection. Okay, so I gave you one more example. I told you now I'm going to spend a little more time on this. See here, this is benzene. I don't know whether I'm creating some problem in your life or not. See here. This is the benzene. And we know aniline is less basic than that of ammonia. Why? Because this lone pair goes in, it goes for resonance inside. We call it delocalization. See, delocalization or resonance can occur only when all the electron cloud is in the same plane. Okay, suppose in the sky, if the cloud is here and this cloud is here, can they merge? This cloud will move in this direction, this cloud will move in this direction. So this cloud can never merge or mix with this cloud. So you just think they are electron clouds. So in this case also, resonance can occur only when if they're in the same plane. Okay, dear. Now, suppose I have put 2 methyl group here. What will happen? Then there will be obstruction. Because this hydrogen and this hydrogen will come near. I'll show you how does it come near. See here. Let me spread out. So in this case, just to avoid this bond pair repulsion, what will happen? See, if this nitrogen which is in the plane, now it will go up. See here. Moment it is in the plane. See, it is in the plane. These are the 2 methyl groups. Okay? These are the 2 methyl groups. And this is the nitrogen. Just to avoid repulsion, what will happen? It will go up. See here. Moment it goes up, then the resonance stops or become less. So, electron on the nitrogen is always available, just like the alkyl amines. So, the basicity is going to increase. Basicity is going to increase because its molecule loses its planarity. Molecule when loses planarity, resonance stops. When the resonance stops, electrons do not get delocalized. It remains on the nitrogen and the basicity increases. Look now. So in that case, what you will find? Suppose I have taken see, it is have the maximum steric hindrance. It is most basic. Why? See, instead of putting hydrogen, I have put 2 methyl side by side. So this, in this case, this lone pair will never go inside the phenyl ring because this is not planar. This is not planar. This is the most basic. Okay. Now I can write it in this way. These examples are given in our entrance exam. Okay. See now. Suppose I have taken this. Now from this side, the steric hindrance is not there. So slight movement of electron will take place. Clear? Now, so this is the steric effect. See here. CH3, 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 CH3. Here no obstruction. Obstruction is not there. So in that case, it will have least basicity. So here we will write. In case of NN disubstituted aniline, the basicity increases due to steric hindrance. So I'll write now here. Due to steric hindrance, the planarity of the molecule is disturbed, and so effective resonance does not take place. Which increases the basicity. Basicity depends upon the density of electron. If the electron moves away by resonance, density decreases, basicity decreases. And if you create a situation where electron does not move inside, basicity will increase. So it is going to behave like alkyl amines. Okay. So I'll go for now the another fact. Please don't think I'm putting a burden on you. Thing which you want to learn, let you learn complete. Never learn piecemeal. Because by learning 1 and 2 theory, you can predict 1, 2, 8. If more examples are given, then you do not know. And these are not difficult. These are very easy. Okay, now we call it hybridization effect. See, in carboxylic acid is what I told you, hybridization effect. Okay, so let me write. Now I'm talking about now nitrogenous compound, not only amines. Okay, so let me write this one. Say this is amine. Because I'm giving more now example for different compounds. This is amine. We know nitrogen, most of the nitrogenous compounds are basic because they eat nitrogen has a lone pair. Now, in aldehyde ketone chapter, I have given you this example that when ammonia or amine reacts with aldehydes and ketones, they form carbon nitrogen double bond, and we call it imine. Okay. Then also we have come across example like this. These are called nitrile or cyanide. Clear? All three of them has nitrogen, and each and every nitrogen is having lone pair. So there should be Lewis base. Look here. What is the hybridization of nitrogen here? It is sp3. What is the hybridization of nitrogen here? Double bond is there, na? So it is sp2. Triple bond, in this case it is sp. So I'll write that percentage of S character of nitrogen. It is 25%. It is 33.3%. And this is 50%. So now we know higher the S character, more will be the electronegativity is applicable for all types of atoms. Electronegativity, or here I am writing nitrogen. Higher the S character, of nitrogen, more will be the electronegativity. And by electronegativity, do they give electron or hold electron? They hold electron, they don't like to give. And lesser will be the basicity. So what we can write now here, basicity is what? As to the acetonitrile, if we add acid also, it doesn't form salt. So you should know.
That's all.
This chemical properties. here now. CH3, CH2, NH. And you added here dilute HCl. What will happen here? You'll get here CH3, CH2, NH3, and it will form salt. Okay, so this is ethyl amine. Here you will get ethyl ammonium chloride. Okay. Suppose you have taken here aniline and you have reacted with HCl. So you will get here instead of writing negative and positive charge, you can write like this also. See, here we call it ethyl ammonium. So what we are going to call it? Aniline chloride, or we can call it aniline hydrochloride. If you have done the reaction with sulfuric acid is a dibasic acid. So aniline is going to take only one hydrogen, okay? So you will get here NH3 HSO4. So it is called aniline hydrogen sulfate. Right. গাড়ি আইব কিন্তু বললো
Yes, sir.
just a minute. Now we'll go for second one. We'll go. Huh? Yes, sir. Alkylation. That you have already done in the preparation of amine. Okay. Suppose I have taken here CH3, CH2, NH. This is ethyl amine. Whatever I mean, primary. Okay. So if you have reacted, you can take any alkyl group. Suppose you have taken ethyl bromide only. What is going to happen now? So we generally add here base also. So you get here CH3, CH2, N, CH2, CH3, H. Okay, this is called diethyl M. Here, secondary M. Then again it will react with this so you get here so you get here the triethyl amine. Is a tertiary. Now if you react it with your excess, na? So again react. So you get down here. See, it becomes quaternary. You have to put a positive charge here. And for that, I have to write here Ni. So it is called tetra ethyl ammonium bromide. Now, if I do it with aniline, so in that case, what is going to happen? I take methyl iodide because methyl chloride and bromide, they are gaseous. Methyl iodide is liquid. So now here you get N-methyl. Again, if you react, you'll get here N dimethyl. And that's all. We will not go further. Okay. So this is aniline. This is N-methyl aniline. That is N comma N dimethyl aniline. So write down. that we evening classes we are having on Wednesday and this one.
No, sir. The one above that. After
This.
triethylamine.
Oh, this is tetraethyl ammonium bromide. Tetraethyl ammonium, then give a gap, then bromide.
Done, sir.